All right, so let's see. Well, I was talking about Uranus being tilted. That the fact that, or the reigning theory right now, or the leading theory, is that there was some kind of collision that tilted it over on its side. Because when the solar system formed, everything would have been rotating around counterclockwise. The way all the planets orbit the sun, and all the planets are spinning that way. Well, except for Venus, of course, which is spinning backwards, is spinning as though its north pole is down, where its south pole should be. At any rate, that's Venus, and then of course and Uranus is tilted on its side. Let's see what else. All right, so and then there's of course there are systems of moons, and yeah, and there is a ring system as well. Okay, I just mentioned that. All right, and then of course Neptune. Neptune, the encounter was, of course, with the Voyager 2 spacecraft, the only spacecraft thus far to ever visit Neptune and Uranus. Neptune does have a ring system. It's kind of shown here, but you cannot see this from the Earth. It's very, very difficult. Only with the most powerful telescopes on the planet. But of course, when the Voyager 2 spacecraft went by, you could easily see it. One of the things that we did see, it was this. They called it the Great Dark Spot on Neptune. Now, Neptune, of course, is further away than Uranus, and it is a little bit smaller, just a tiny bit smaller. But it turns out that the Voyager 2 spacecraft recorded some of the most powerful winds in the atmosphere of Neptune. And which is still a little bit of a mystery to us, why the winds are traveling at the speeds they are. This in the foreground right here is one of the moons of Neptune. The Voyager spacecraft passed by and took a picture of. It took lots and lots of pictures in 1989. As it was just passing by. It only had like a little window of several hours to actually take pictures. Let's see. So Neptune is definitely more blue than Uranus. Uranus again is more of a greenish blue. It has hydrogen and helium in the atmosphere, but of course there's methane and ammonia as well. This was the first planet that was discovered mathematically before it was actually discovered physically. Mathematically, because we used, knowing the orbit of Uranus in the late 1700s, we figured out that there was another object out there, which turned out to be Neptune, and mathematically. I think it was a German mathematician. I forget his name, Galilei or something like that. He predicted where this object would be, and just within like a couple of days of him passing on that prediction to the Berlin Observatory, it was discovered. This object was discovered, and yeah. So, here's an interesting thing about Uranus. I just remembered. You can actually, if you know exactly where to look, it's barely on the edge of what the human eye can see. Most human eyes can see. It's what we call a sixth magnitude object. That's the brightness of it, and that's barely on the edge of what the human eye can see. And so there was actually, if you go back and once we found Uranus, you can go back in history, and there were different people who actually cited it, but they didn't know that it was a planet. Like they didn't realize that this was an object that was going around the sun. Neptune is far too dim to actually be able to see it, unless you use. It actually needs a pretty good telescope to be able to see that. Um, not your average um, backyard telescope. You need a pretty decent one. What I mean by that is you got to spend several, so close to, I'd say probably $500-$600 to get a telescope that's powerful enough to be able to see Neptune. All right. And at any rate, I was talking about this. So this great dark spot, which was seen by the Voyager spacecraft, when the Hubble Space Telescope was launched in 1990, and then it had to undergo some repairs. But when we turned the Hubble Space Telescope to look at Neptune, to see what was going on with the great dark spot, it was completely gone. And so this was a very short lasting storm on Neptune. What else? What else do I have to say about Neptune? So it's the end of the solar system, of the planets in the solar system. Of course, it's the eighth planet. There used to be a ninth planet, was called Pluto. Of course, it's still called Pluto, and it's still there. It's just that in 2006, it was voted on by the astronomical community to call it a dwarf planet. And let me give you a little background about that. Okay. So the region beyond Neptune is now called the Kuiper Belt. All right. At which it turns out that Pluto is the largest member of the Kuiper Belt. But that wasn't really known before. Around, I think it was 2003 or 2004, I can't remember exactly which. There was an astronomer that at the time was working at UCLA, and his last name was Brown. I forget what his first name is, but anyhow, he discovered an object, and when he did, beyond the orbit of Pluto. So this is when Pluto was still considered a planet. He found an object, and when he did his first calculations, it was bigger than Pluto. It turns out that it's not bigger than Pluto. It's actually a little bit smaller than Pluto. But when he originally did his first calculations, it showed the mathematics. He based it on some observations that he had, and they needed more observations to be able to actually come up with the actual size of this thing. Anyhow, it turned out to be his original calculation turned out to be bigger than Pluto, and not only that, it clearly had its own moon. Just like Pluto actually has a system of 3 moons. The largest moon being named Charon or Charon, depending on how you want to pronounce it. It begins with a C, so I like to pronounce it Charon. At any rate, so this other object, it was found in 2003, and this guy went home to his wife and said, "Hey, I think I found the 10th planet." And so there was lots and lots of debate that went on for several years. And when it was finally said and done, this object turned out to be, and the object now is called Eris. Anyhow, Eris turned out to be slightly smaller than Pluto. But then, this guy said, "Hey, well, even though it's smaller than Pluto, it's still, an object out there. So the astronomical community had to get together, and this was an international effort. They voted in the vote. It was a kind of a crazy vote. I remember this quite well. It was, there was a point in the voting where they had to define what a planet was, basically, which is not as easy as it might sound, right? Like, for example, if you just say anything orbiting the sun is a planet, and if it's anything that orbits the sun and can self-gravitate is massive enough to self-gravitate into a sphere is a planet. All right, so That's not the definition, by the way. But there, at one point during this big debate, that was that was going to be um, the definition of a planet, and then would have been like hundreds of planets, right? Because our moon is big enough to be round, to self-gravitate into a sphere, and it, of course, it orbits the Earth, but it also orbits the sun. So, our moon would have been considered a planet, and so forth. So they said, well, no, this is getting out of hand, and so finally, the astronomical community, again, it was a vote, said, okay, you know what, let's define the planets. And the one thing that they said um, is that the planet has to clear out the area of of most debris in the area of where it orbits the sun. And see, Pluto fails in that because there's lots and lots of material right at the same orbit as Pluto. Pluto's actually really weird in its orbit. Like it's extremely elliptical. Like here. Let's see if I can do this with the mouse. So it's more like a comet going around the sun than it is a planet. The planets are elliptical when they go around the sun. That's of course Kepler's first law, but they're almost circular. They're really close to being circular. In fact, that's why it took Kepler so long to figure that out. But at any rate, Pluto is so weird in its orbit that it actually in its orbit, which takes hundreds and hundreds of years to orbit the sun once. There's a period where it gets a little bit closer to the sun than Neptune, which is really odd. Now, people often ask me, okay, if that's true, will Pluto ever collide with Neptune? And the answer is no. We've worked out, using supercomputers, we've gone, millions of years into the future in the orbits of Pluto and Neptune, and they'll never ever get close to each other because Pluto is tilted. The orbit of Pluto is tilted greatly with respect to what's called the ecliptic, where you find the sun and all the other planets, the plane of the solar system, right? So Pluto is tilted, and so it never ever really gets close to close enough to Neptune to collide with it, at least according to our computer calculations. And that's, you're projecting hundreds of millions of years into the future. All right, so there's this new region beyond the orbit of Neptune called the Kuiper Belt. Again, Pluto is the largest of the Kuiper Belt objects, and so it was reclassified as a dwarf planet. Not all Kuiper Belt objects are dwarf planets, but Pluto, of course, is a dwarf planet, and we've actually visited Pluto in I think it was 2016. The New Horizons spacecraft passed by Pluto. It was just a flyby and took pictures of Pluto and Charon. And the other moon, what are the other moons' names? Nix, and I forget what the other, I think it's Hydra or something like that. At any rate, took pictures of him. Charon and Pluto are actually really almost the same size as each other. It's a very odd little system. What else? Which planet is more dense than water? All of them, okay? Except for Saturn. Saturn is actually less dense than water. The Earth's moon. Okay, so let's turn to the moon. So the Earth it's actually a pretty substantial moon. As far as moons go, it is the largest moon compared to its host planet, right? So it's about a fourth the size of the Earth. Again, that there are lots of moons that are bigger than Pluto, right? Like, Ganymede, which is the largest moon in the entire solar system. But our moon is really large compared to the planet that it orbits. And It has no atmosphere.